Welcome back to Calculus 1. We're in homework set number 5, working on problem number 6. The solution is that yes, we can get them to fit. Now let's go ahead and see how.
Here's our problem. We've got a box that is going to hold two rods, and the box is 2 centimeters. I'm just going to redraw that. 2 centimeters in height this way. And so certainly this box, and it's also 8 centimeters in length. Now certainly this figure can hold two rods that are each two semicircular rods that have a radius of 2 centimeters. So it can hold these two guys. The question is, can the same box, or excuse me, can the same two rods fit in a box whose height is, again, 2 centimeters, but whose length this way is only 7.6. So here's what we're going to do. We're going to take the same box, actually. Let me just delete that. And what I'm going to do, so actually I can't take the same box. Let's we got to move this down just a little bit. Okay, so let's come down here. Instead of going to 8, we're going to go to 7.6. Now, how are we going to fit those same rods in there? Well, what we're going to do are these same circular discs. What we're going to do is we're going to take the first one and put it in there normally like that, and then the second one we're going to try to fit it in something like that. So here's what we've got. Again, they both have that diameter, or excuse me, that radius value of 2. Now, clearly they don't fit next to each other because we'd have 1, 2, 3, we'd have 8 altogether. So 2, 4, 6, 8. So we need 8 centimeters, and we only have 7.6 centimeters. But the question is, can we rotate one and put it in there? Well, this length, let's go ahead and see how we would do that. This length right here is 2 centimeters. Okay. Also, this length up here is 2 centimeters because that's what the radius of each of the discs are. Now, what we need to figure out is if we take the two radius values and we draw them in between, this, okay, is this length long enough to hold 4 centimeters? That's the question. So this isn't too hard to figure out. Okay, what we're going to do is we're going to see how far this is right here. Well, if the total is 7.6 centimeters, and I've used 2 up top, so 2 here, and then another 2 here, I've used 4 centimeters already, just in this length here and this length here. So when I do my subtraction, I end up with 3.6 centimeters left. So this guy here is 3.6. Now what we're going to do is we know the height value here, that's 2 centimeters. So if I redraw that triangle, now again, what we're looking for is this distance right here. We need it to be 4, because if it's 4, it can hold both those radii. Okay, so we want this to be equal to 4 centimeters, or at least 4. If it's more than 4, great. So this is 2, this is 3.6. Again, I've dropped a right angle here, so that makes this a right triangle. Okay, so if we take 2 and we square it, so this distance, the purple distance that we want to be 4, is going to be equal to 2 squared plus 3.6 squared, square root of that guy. So that's going to be 4 plus 12.96. Okay, and so if we take the square root of that, we end up getting, let's see here, 4.1182 centimeters. So this length right here is 4.182, and we only needed at least 4. So we've gotten more than 4. This length is more than 4, so clearly these two will fit in there. So the answer is yes, they will fit. But on a test, if you just say this is not worth any points, or maybe 1 point, this right here and this picture right here, that's where you're going to get your points.